All right, guys, got some pen issues today, but I think I fixed them. So here we go. Conditional probability formula. So it's on the formula sheet. And so basically, you have this idea that the probability of uh, A and B is equal to the probability of A times the probability. The probability of B, let me go backwards here, of the probability that B given A happens. Okay, so this is our like general multiplication rule kind of thing. So now what they're saying is, well, what is the conditional piece? Well, if we solve for this, we're going to divide both sides by probability of A and the probability of A. So the conditional probability piece of B given that A happens is going to be the probability of A. Whoa, I am way ahead of myself. Probability of A and B over the total probability of A happening. That is our conditional probability piece. Okay, so it all boils down to this. It's the probability of both events over the probability of the given event. Okay? All right, so if we're dealing with this, most common way that they lose credit is they don't show work. They just give an answer. So make sure you show your work. That's the common way they lose credit. So how are we going to fix that? We're going to fix that by always show your work, including stuff like the probability of B given that A happens is the probability of A and B over the probability of A. And then you would just put your decimals in here. Let's say it was like 0.37 divided by 0.64, and my probability would be 0.5. So make sure you show stuff like that, okay? All right, so let's go ahead and we're going to go to the media usage one that we did the other day. And we're going to say the probability that they are heavy users of media and they get good grades. Okay. So how do we figure that out? Well, it's a conditional probability. So it's the probability. Whoops. Let's go backwards here. It's the probability that they're heavy media users and they get good grades over the probability that they get good grades. Okay, so we need to find the total good grades. All right, so we're going to go back here. Let's see if I can find it. Hopefully, let's go back to last week. I think it was Friday. Let's go. We do a tree diet. There it is right there. Okay, so what we want is we want the probability. So we're going to look at this right here. So we're dealing with heavy users. The probability that they are heavy users that get good grades. So that probability is going to be the probability of 0.21 times 0.52. Okay, so let's go back to our other one. So we're going here. So the probability, so we're going to end up the probability that they're heavy users that and they get good grades, is equal to 0.21 times 0.52. So we just went down the tree chart. So let's go here. So we need to know the heavy users. Let me see if my highlighter works this time. So we wanted the heavy users. Oops. It does not like to work on this one. Works on my other one. Don't know. You guys are bad luck. So wonder why it won't work. One more try. Oh, my lights just went out. Okay. So we'll go back. So the whole idea is this, that we need to follow this trail right here, because this is the heavy users that get good grades. Now, what we also need to do is we need to come up with the probability that they're medium users that get good grades, plus the probability that they're light users that get good grades, plus the probability that they are heavy users that get good grades, because that's the total of getting good grades. So we have all three of these we got to work out. So we got to do the medium users, which is right here. So the medium users is going to be 0.62 right here, times the ones that get good grades, which is 0.68. So 0.68 plus the probability that they're light users that get good grades, which we figured that total out right here. So I'm just going to write that one in, 0.1258 plus this one up here, which is going to be 0.21 times 0.52. Okay, so if we do all that math there, if we pull all that together, let's see what we come up with. So, where'd it go? So we're looking at, let me get to my other page here, guys. We're right here. So we are looking at the probability. Let's rewrite this. I need a little bit more room, so I'm gonna go. Nope, that didn't work. I don't know what that is. There we go. So we know we have this, and then we need to do over the probability of all that other stuff from the other page. So we know we have 0.2152 all over, which my lights went out, so I can't read, which is going to be, which is going to be 0.1098 all over 0.1258 plus 0.4216 plus 0.1098. Now don't forget, this is the light users that got good grades, the medium users that got good grades, and then now the heavy users that got good grades. Because we want the total good grades, total good grades. So if we add all that up, it equals 0.6566. 0.6566, which then that ends up becoming 0.166, or 16.6% of the students get good grades. Are heavy users if they have good grades. Okay. All right. So remember, it is the idea. Let me shrink this back down, guys. It's the idea that it is the total of both events, total of the given event. And so for this one, the event is heavy users and good grades, and then the given event is that they have to have good grades. All right. So let's look at this one. So now we're dealing with drug tests. So if we look at this, we know we have the idea that they have drugs and we have no drugs. And so there's 4% of the people that actually use drugs in this one. And then that means 0.96 don't use drugs. But when they take a drug test, the number of people that use drugs that test positive is 0.9, and the number of people that test negative is 0.1. Well, now, if you go the other direction and you say, okay, I don't use drugs as a prospective employee, that they're going to get a false positive of 0.05. Okay? This is a false negative. This is a false positive. So the idea of a false negative is the employee is taking drugs and they come out negative, so they don't come up as they're taking drugs. And then a false positive is they're not taking drugs and they end up testing that they do take drugs. So then this side would be 0.95. So this is negative. All right. So if we look at this piece, we need to multiply through here. So this would be you take drugs and you come up with a positive. This is going to be 0.04 times 0.9. You take drugs and it's a negative, so this is a false negative. It's 0.04 and it's times 0.1. This one, you don't take drugs, no drugs, but you test positive, which is a false positive. So this is a false negative. And this is a false positive, 0.96 times 0.05. Okay? And this is a false positive. Now, this is where you take no drugs. You test negative, like you should, and it is 0.96 times 0.95. All right, so let's look at this. So what they want is they want first the probability that they're going to test positive. So if we look at this, testing positive. So this is a positive test, and this is a negative test. So to test positive is going to be the idea that they test positive, which is going to be the top one, 0.04 times 0.9, plus the idea that they a false positive, which is going to be 0.96 times 0.05. So that cleans up to be 0.036 plus 0.048, which I don't know exactly what that comes out to be. We're looking at 0.084. We're looking at 0.084. So that is the percentage. 8.4% of the people test positive. Now they want the probability for B. They want the probability that they took the drug and they tested positive, which is going to be the probability of the conditional statement, which is going to be drug positive, divided by, the and. Let me go backwards here. Oops. They took the drug and they tested positive over the probability that they tested positive. So if we look at this, the probability that they took the drug and tested positive is equal to 0.04 times 0.9, which is that top one up here. And then we want that over the probability that they tested positive, which is, we already figured that out. The probability that they tested positive, which is 0.084. So we have 0.036, wow, backwards, 0.036 divided by 0.084, which, if you do the math on that one, you come up with 42.429. 0.429 or 42.9%. All right, guys, conditional probability rule. Takes a little bit. Tree diagrams are great for this. Hang in there. Don't forget your homework's right here, page 330. This is the last part of chapter 5. Good luck to you. We'll see you soon.